All right. Hello, everybody. I'm Mr. Huber, and I'm going to kind of walk us through our remediation sheet to help us study for that retake today. All right. So if you want to go ahead and go to your Schoology page, in that retake folder, you'll see the Chapter 2 remediation sheet, and we're going to have to get that done before we retake our Chapter 2 test. So go find that right now. All right. Hopefully you can see our test remediation. So I went through and I labeled each of our targets. All right. So this is the makeup of our Chapter 2 test. So I'm going to quickly kind of go over each of these targets. All right. In the video, I'm going to go ahead and hold up the number of fingers as the target that we're on. So you can even skip around because maybe you already know target 1. So you're going to skip to target 2. That's fine. You can jump to wherever you want in the video and just listen to the problems that you need help doing. Your test remediation sheet should hopefully look like this. All right, and we're just going to take time now to go through each one of these problems. All right, so the first target is I can evaluate and identify functions with function notation. All right, so this first one, we have a graph. All right, now whenever I'm determining if a graph is a function or not, I do what's called the vertical line test. So if at any time you can draw a vertical line, and that vertical line goes through 2 points of a graph, then it is not a function. So this one right here, we would put no, it is not a function because that vertical line hits 2 points on your graph. All right, but if I go to number 2 here, now we have a table. All right, on our tables, we really want to focus on our x values. X is your input. You cannot have 2 of the same input with a different output. All right, so we really want to make sure that none of our x values are repeated. So in this example, we have 0, 1, -2, 1. Uh-oh, we have a 1 here and a 1 here. That x value is repeated. We cannot have that. So this one would also not be a function. In our third one, we're back to another graph. So again, we can try our vertical line test. So we can make a whole bunch of those vertical lines and see how each vertical line only hits 1 point on your graph. So this one would be a function. Yes. All right, so now we're going to play a quick little game. You have to tell me, is it a function or not? All right, so here's our first one. Decide now, is it a function or not? Hopefully for this one, you said, okay, well, we could draw our vertical lines and it hits at 1 point. So this one would be a function. What about this one here? Function or no? Well, if we drew a vertical line, it would most definitely go through 2 points. So this one would be no, not a function. All right, third one. Yes, a function. No, not a function. Drawing our vertical lines. They are each only going to go through 1 point of that graph. So this one, yes, it is a function. What about this one here? We have a circle. This one, vertical line goes through 2 points, so we would say no, not a function. All right, I think we're getting the hang of this now. Maybe let's do a couple more. This one here would not be a function because, see, on this vertical line, it hits a whole bunch of points. So this one we're going to say no. This one here, well, a vertical line hits all of these points. So this one is definitely not. And let's do one more. This one we have a horizontal line. So horizontal line, each of my vertical line tests only hits 1 point. So this would be a function. All right, let's get back to our remediation sheet. Next one. This is what we call function notation, and that's what this f of x means. That's your function. All right, so you're going to have some value that you're going to plug into your function for x. And in this one, it tells us that value is -2. So what I'm going to do is I'm going to take that -2 and plug it in wherever I see an x. So we actually have 2 places that we need to plug that into. All right, so we're now finding f of -2. So I have 4 times -2 squared plus 6 times -2 minus 8. And whenever I plug in a number, I always put it in parentheses just to show that that's what got plugged in. All right, -2 squared is really -2 times -2. So that would give me a +4. So I have 4 times 4 plus 6 times -2 should give you a -12. And then we have -8. All right, so I have f of -2 is equal to 4 times 4 is 16 plus -12 minus 8. Almost done. F of -2 is equal to 16 plus -12 should give us 4. And then we have 4 minus 8, or 4 plus -8. So f of -2 should be equal to -4. And this would be your solution. So when you have an input of -2 or an x value of -2, your output or your y value is going to be that -4. All right, let's try one more like that. In this one, we have f of 4. So now I want to plug, let's do it in blue this time. I want to plug 4 in for my x values. So I have f of +4 is equal to -2 times 4 squared minus 3 times 4 plus 5. All right, so I have f of 4 is equal to -2. 4 times 4 is 16. 3 times 4 is 12 plus 5. F of 4 is equal to 16 times 2 should give you what, 32? So -32 minus 12 plus 5. So f of 4 is equal to -44 plus 5. So I got f of 4 is equal to -39. And that's how you do those 2 function notation questions. All right, we're going to change gears a little bit. We're going to move into target number 2. I can find domain and range. Okay, so whenever we look at domain, we're always looking at our x-axis, and I'm going to do domain in orange. So domain is always going to be left and right. All right, so if I look at this graph, I want to determine how far it goes to the left and how far it goes to the right. All right, but as I kind of look at this graph, notice that if I extend this, because it's an arrow, so we know that this graph continues on, see how it's going ever so slightly to the left and ever so slightly to the right forever. So this is going to all of your negative, -1, -2, -3, -4, and on. So since it's going to the left to all of our negative numbers, I'm going to say it's going to negative infinity. And then to the right, it's going to 6, 7, 8, 9, and on forever and ever and ever, because this graph never ends. So I'm just going to say it's going on to infinity. All right, now since the graph can never actually reach the point infinity, we use those parentheses. All right, but now let's go ahead and shift gears a little bit. We're going to look at range. All right, range we're going to do in blue. Range, we're now not looking left and right, we're looking down and then up. All right, so I go down to this point right here, and see how that's on that y. Your y value is that -3. So I'm going to say, well, it's right on that -3. So whenever you want that number included, we use this bracket. All right, that means it could be on -3. All right, and then we have to say, well, what does it go up to? Well, this graph really goes up forever and ever and ever. All right, so we'll just say to infinity. And again, with infinity, it can't actually be on infinity, so we use that parenthesis. All right, let's try a couple more. Okay, domain. So remember, left, then right. So left, I see it goes to this point right here, which is on that x is equal to -5, right? So I'm going to say -5 to the right side, which it goes to 4, and it's on that 4, that x is equal to 4, so I'm going to use that bracket. All right, and then range. Range, remember, down, then up. So it goes down to, it looks to be this point right here. So I'm going to say that's y is 3. And then up to +3. So this one should be a -3, sorry. This one should be a +3. There we go. And now, using this domain and range, you're not telling the person exactly what the graph looks like, but you're telling them, hey, it's between somewhere in this box, because we can find it on the left and the right and the top and the bottom. So it's somewhere in this box here, which is helpful. All right, let's look at one more. So again, domain left, then right. So left, we go to this point here, which is that x is equal to a -5. So I'm going to say -5, and to the right, 8. And since it's on that, I want that -5 point, and I want that +8 included. So I use the brackets. Whenever it's included, brackets. All right, and now let's switch to our range. So range, remember, down then up. So it goes down to that -9 and up to -2. So I'm going to say -9 all the way up to -2. And those are both included. All right, so that's kind of a quick overview of our domain and range for target 2 on our test. But now let's jump into target number 4. So this is target 4. All right, target 4, we're going to talk about equations of a line and how to graph that line. So we have 3 different equations of a line, and I'll write those out for us right now. The first one is slope, intercept, form, and that is y is equal to mx plus b. All right, now this equation tells us some good information. First of all, this m, I'm not exactly sure why they chose m, but m always represents slope. So I'm going to write that in there now. So m is slope. And then this b value at the end here, that b value is your y-intercept. Okay, so let's look at an example in slope-intercept form. Okay, if I had this equation, my slope, okay, is what comes right before your x. So in this example, my slope would be negative 2/3. Your y-intercept is this constant at the end. So in this case, it would be a positive 4. So I'm going to write that as my b value, positive 4. So now we look over at our graph. Remember, this is your y-axis. So I want to make a point at positive 4. So I'd say 1, 2, 3, 4. Here's my point. Now we use that slope to find other points. Okay, so remember, slope is rise over run. Okay, and if it's negative, we want that to go up and to the left. So this is our negative slope. So I'm going to go up 2, left 3. So up 1, 2, left 1, 2, 3. Up 1, 2, left 1, 2, 3. You could even go down and right if you wanted. So I could go down 1, 2, right 1, 2, 3. Down 1, 2, right 1, 2, 3. All right, and the last step would just be to connect these points. And if you hold your pencil down at the end on notability, it makes it a straight line for you, which is pretty nice because I know I draw some very squiggly graphs. All right, and that would be all to graphing in slope-intercept form. All right, but now our next equation of a line is what we call point slope form. All right, and point slope form is y minus y1 is equal to mx minus x1. Remember, this m is still our slope, just like in that first one. So I'm just going to label this again, slope. All right, but now we're being told a point as well. And that point is going to be this x1, y1. All right, so let's go ahead and write that down too. We have a point, x1, comma, y1. What we have to watch out for, though, is these minus signs. So these minus signs tell us the opposite. All right, and we'll look at that in a minute. So I'm just going to put opposite just so we don't forget. All right, so here's our example. So again, we said slope comes before that parenthesis. So I'm going to say, okay, well, in this one, our slope would be that positive 1/2. So I'm going to say slope 1/2. And our point, well, our point is going to be the opposite of that -4. So that would be a positive 4. And then the opposite of this plus 5, so that would be a negative 5. So let's go ahead and plot that point now. So 4, negative 5. So 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 5. So that point would be right there. This time we have a positive slope. Okay, so our slope is still rise over run. Okay, and since it's positive, it's going to go up and to the right. So I want to go up 1, right 2. Up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. And we can see our lines start to form. Now all we have to do is connect these points. That's all there is to it. Okay, now I did mention that there are 3 types of equations that we might see. That third one is what we call standard form. Which is ax plus by is equal to c. So for an example of this, it might be like 2x plus 4y is equal to 64. And the reason we don't really like standard form is because this tells me nothing. It doesn't tell me a point. It doesn't tell me the slope. It doesn't tell me a y-intercept. So standard form's kind of not my favorite. All right. Now we could convert standard form to be either slope intercept or point slope form. All right. But it's just extra steps. So I prefer, my favorite is this slope intercept form. I don't know. I just feel the most comfortable graphing that one. All right. Target number 5. Target number 5 goes based off of target number 4. So we need to know target 4 before we move on to 5. All right, so let's take a look at 5 now. Target 5 says I can write linear equations in slope intercept and point slope form. Okay, so this one says write an equation for a line that goes through the point. So we have our point. Your point is 5, 2, and has a slope. That slope is negative 3. Always look what the question is asking for. So this one wants point slope form. So I'm going to go up here and I'm going to say, okay, point slope form. This is our formula. So I'm going to plug that in down here. So our formula was y minus y1 is equal to x, or not x, m x minus x1. Remember, your m value is your slope. So it told us that we have a slope of negative 3. All right, now watch out for our point. Okay, this point is going to be x1, y1. All right, so this y1, notice, is a positive 2. So I want this to be minus 2. And then x1 is a positive 5, so I want this to be minus 5. All right, and that's it. That is your equation in slope, or in point slope form. All right, there's nothing else that we have to do on this one. We did it. All right, so now let's move on to number 12. Number 12, write an equation that has a slope of 5 and goes through the point 0, 11. All right, so let's mark. We have a slope of 5, and we have the point 0, 11. So again, I'm thinking, okay, I have a slope and I have a point. Let's use point slope form. So I'm going to go ahead and write this out. Y minus y1 is equal to mx minus x1. All right, it told us our slope, that m value is 5. Then we plug in our point. So that y is a positive 11, so I want it to be minus 11. And that x1 is 0, so I'm just going to have it be minus 0. However, this time we're not done. Okay, because the question asks write in slope-intercept form. So remember, slope-intercept form is that y is equal to mx plus b. So we have to change how this is written, and here's how we're going to do it. First, we're going to distribute our slope, or distribute that 5 to both of these terms. So I get y minus 11 is equal to 5 times x is 5x, minus 5 times 0, well, anything times 0 is just 0. Now, do we have to write minus 0? You don't have to. But I wanted to show you guys that we need to distribute it so that you don't forget when it's not 0. All right, so this kind of just goes away because it's 0. All right, and my next step, I need to get this y by itself, okay, because it's y all by itself in the formula. Okay, so I'm going to add 11 to both sides. Now, this is a very common mistake I see. People want to go, okay, well, positive and negative 11 cancel, so I get y by itself. Awesome. But here's what they do. They say, okay, 5 plus 11 is 16x. No, 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 no. Do not do that. Okay? This is a 5x. 11 is just a constant. It does not have an x variable, so therefore we cannot combine them. So I would just say 5x plus 11. And now this is our slope-intercept formula. On to number 13. Write an equation of the line that passes through, oh, we have a point. All right, so I'm going to highlight that point in blue like I've been doing. And is perpendicular to a line whose equation is y is equal to 4 over 5x minus 4x, minus 4. Whew. All right, here we go. This one says, write in point slope form. So I'm going to write my point slope form. So that was that y minus y1 is equal to mx minus x1. Okay, we can plug in that point right away, right? So I know that y is a positive 9, so I want it to be minus 9. And then I know that x is a negative 3, so I actually want it to be plus 3. So I'm going to change this to be plus 3. Oh, but now I'm stuck. It doesn't tell me what the slope is. Well, that's this part right here, perpendicular to the line whose equation is y is equal to 4 over 5x minus 4. All right. Well, we know it has something to do with this equation. So I want to find the slope of this equation. And this is in slope-intercept form. So remember, in slope-intercept form, your slope is right before that x. So here I could say your slope is equal to 4/5. Okay, but now we have to know the difference between a parallel slope and a perpendicular slope. So parallel, okay, maybe the slope is up 4 over 5 for this line right here. A parallel line would also have a slope that was up 4 over 5 because these two lines never intersect. That's what parallel means. They run right next to each other, but they never actually touch each other, all right, ever. All right, so this parallel, and this is the symbol for parallel, like two lines just right next to each other. that would be exactly the same, 4/5. However, a perpendicular slope, okay, I'll do in red here, this perpendicular slope looks something like this, and it intersects at that right angle. So that's why this is our sign for perpendicular slope. Okay, now there's two things that happen on a perpendicular slope. It becomes the opposite reciprocal. Opposite reciprocal. So here's what happens. It was 4/5. So now the perpendicular slope is the opposite. So see how this is positive? Now it's negative. And then the reciprocal means that we flip-flop our numerator and our denominator. So 5 is now your numerator and 4 is now your denominator. So you have to do almost like a double swap. So our answer for that perpendicular slope would be -5/4. Okay, so that's what I would plug in for the slope of this line, -5/4. So this would be our completed formula in point slope form. All right, this one says write the equation of the line given the graph in any form. So you get to pick point slope form or y-intercept form. The first thing I like to do is find that slope. So I'm going to find that by doing rise over run. And I'll do that with these 2 points, this point here and this point here. So I'm going to go up 1, 2, 3, 4. So your rise is 4 over your run is 1, 2, 3, 4, 5. 5. But since it's to the left, this would be a -5. It's going toward these negative numbers. All right, so our slope would be a -4/5 slope. Okay, because this graph is going up and to the left. So that makes it a negative slope. All right, now it depends on what formula you want to use. So we could use our slope intercept formula and we could say y is equal to mx plus b. All right, and we just found that m value to be that -4/5. And then our b value, remember, is that y-intercept. So I would say, oh, well, this is at 1, 2, 3 is where it crosses that y-axis. So I would say +3. Or we could say y minus y1 is equal to mx minus x1. We found m, our slope is that -4/5. All right, and then we could use, I don't know, maybe this point right here. So this would be 1, 2, 3, 4, 5, -1. So I could say, okay, 5 is my x value. So I'm going to make it -5. And -1 is my y value. So I would make this +1. Okay, so these would be kind of your two options for this equation here. Either of these equations would work. All right, moving right along. We are now in target 6. Target 6, it says, I can solve absolute value equations and inequalities. All right, so if I look at this first one here, I'm like, ooh, there's a lot going on here, right? Well, here's what I want to do first. I want to try to isolate this absolute value to get it by itself. All right, so what I'm going to do is I'm going to get rid of that -5. So I'm going to go ahead and add 5 to both sides. Okay, that cancels that out. So I get 3 times the absolute value of 2x minus 4 is equal to 7 plus 5 should give you 12. All right, but now I'm going to get rid of that multiplied by 3 by dividing each side by 3 so that these cancel, and I get the absolute value of 2x minus 4 is equal to 12 divided by 3 should give you a positive 4. All right, now with absolute values, you're going to have 2 answers. Okay, because this could be a positive 4, or it could also be equal to a negative 4, because when you take the absolute value of -4, it's equal to positive 4. All right, so I have to now set this equal to 2x minus 4 is equal to positive 4, and 2x minus 4 is equal to a negative 4. So now let's solve both of these. Maybe I'll do it in green. So I'm going to add 4 to both sides. I get 2x is equal to 8. Divide each side by 2. I get x is equal to 4. I'm going to add 4 to both sides. I get 2x is equal to 0. Divide by 2. I get x is equal to 0. So let's see if both of these work. All right, so we want this to equal 4. So the first one I'm going to plug in is positive 4. So you have the absolute value of 2 times 4 minus 4. Okay, so this would be the absolute value of 8 minus 4, which the absolute value, 8 minus 4 is 4. The absolute value of 4 is equal to 4. So these two match. So we're good. We did that first one correctly. Let's see if our second solution works just the same. So the second one, we got x is equal to 0. So I have 2 times 0 minus 4. 2 times 0 is just 0 minus 4, which would equal the absolute value of negative 4, which the absolute value of negative 4 is 4. So we're good. We found our 2 solutions to this one here. All right, so these would both be solutions. So x is equal to 0 and x is equal to 4 would both work. All right, if we look at number 16, exact same way. First, I'm going to get rid of that multiplied by 5 by dividing each side by 5 so that I get the absolute value of x plus 2 is equal to 4. All right, now remember we have 2 solutions. So it could be positive 4, but it could also be x plus 2 is equal to negative 4. So now let's just solve both of these. Okay, because we did positive and negative, these absolute value signs now kind of go away. All right, then we just subtract by 2 on both sides. Should get x is equal to 2. And x is equal to negative 6. Hello.
Hi there.
How's it going?
Do you have